on HOD Professor K.J. Chaturvedi sir, my seminar guide Rajan Parikh sir, my seminar coordinator K.P. Sharma sir, faculty members, examiners, and my batchmates. I am Tushar Gushaiwal, pursuing my Bachelor's of Technology from University Department in Mechanical Engineering, Rajasthan Technical University, Kota. Today I am here to present my seminar topic presentation on laser ignition system under the guidance of Sir Rajan Parikh. So let's start with the first slide. These are the topics of my presentation. Here is an introduction about ignition system. Ignition system initiates the ignition and then further combustion takes place in the combustion chamber. Due to globalization, there is a sharp increase in number of vehicles. So to get the fuel economy as well as less harm to the environment due to engines, emission advances in combustion process and ignition systems are required. Since new coming engines are complex, so they have to burn the different variety of fuels, so combustion mechanism also has to be advanced to meet the future goals, performance, fuel economy, and the emission standard. To overcome the weakness of conventional ignition system, one of the alternatives is laser ignition system. Now let's take a look at the brief introduction of laser. Laser is a device that emits light through a process of optical amplification based on the standard emission of photons. The term laser is an acronym for light amplification by stimulated emission of radiation. A laser is created when the electron in atom in special glasses, crystals or glass absorbs energy from an electrical current or another laser and become excited. The excited electrons move from a lower energy orbit to a higher energy orbit around the atom's nucleus. When they return to their normal or ground state, the electron emits photons. These photons are all at the same wavelength and are coherent, meaning the crest and thrust of the light waves are all in lockstep. In contrast, ordinary visible light comprises multiple wavelengths and is not constant. Now let's know about the historical background, in which some scientists and engineers had done some experiments. On the basis of experiments, they represented their theory. The first demonstration of laser-induced optical breakdown phenomenon in the air can be considered as the starting point for research on laser ignition. In this experiment, a frequency triple Q quotient ruby laser pulse was focused by a lens and generated plasma comparable to an electrical discharge between the electrodes of a spark plug. Probably due to the experimental complexity, the authors described their setups as the most expensive spark plug in automotive industry. The second experiment is done by Lee and Aristoteles in 1969, in which the ignition of chemically reactive gases mixture is done in a combustion chamber using a UV laser Q switched by a rotating roof prism and saturable absorber dye set, and yielding single 10 nanoseconds duration pulses. The minimum energy required to induce breakdown was found to be 1.2 joules. This experiment shows a strong connection to the dynamics of the decaying glass for both detonable and non-detonable mixtures. Here are some basic definitions. What is laser ignition? It is the process of starting combustion by the stimulus of a laser light source. Basically, laser ignition is an alternative method for igniting mixtures of fuels and oxidizers. The phase of the mixture can be gaseous or liquid. The method is based on laser ignition devices that produces short but powerful flashes regardless of the pressure in the combustion chamber. Q switching. It is a technique which allows the production of light at a very high peak power for a very short time. It is also known as giant pulse formation or fuse coiling. It's a technique by which a laser can be made to produce a pulse output beam. The technique allows the production of light pulses with extremely high peak power, much higher than would be produced by the same laser if it was operated in a continuous wave mode. Pulse laser. Pulse lasers operate in a pulse mode, that is, they switch on and off very quickly. The current record for the shortest laser pulse is just under 4 femtoseconds. Plasma. Heating a gas may ionize the molecules or atoms, thus turning it into a plasma. Let's know about the drawbacks of conventional ignition system. The location of spark plug is not flexible as it requires shielding of plugs for immense and fuel spray. In conventional spark plug, location of the spark plug is fixed as compared to the laser induced spark plug. It is not possible to ignite inside the fuel spray. It requires frequent maintenance to remove carbon deposits. Linear mixtures cannot be burned efficiently. Degradation of electrode at high pressure and temperature. Flame propagation is slow. Multi-point fuel ignition is not feasible. Higher turbulence levels are required. Types of lasers. There are 5 types of lasers. The first one is gas laser. A gas laser is a laser in which an electric current is discharged through a gas to produce coherent light. The second one is liquid laser. The liquid laser is a laser that uses a liquid crystal as the resonator cavity, allowing the selection of emission, wavelength and polarization from the active laser medium. The lasing medium is usually a dye doped into the liquid crystal. The third one is semiconductor laser. A semiconductor laser are solid-state lasers based on some semiconductor gate medium, where optical amplification is usually achieved by stimulated emission and an interband transition under conditions of a high carrying density in the conduction band. The fourth one is solid-state lasers. A solid-state laser is a laser that uses a gain medium that is a solid rather than a liquid in a dye laser or a gas in a gas lasers. And the last one is fiber laser. A fiber laser is a laser in which the active gain medium is an optical fiber doped with rare earth elements such as erbium, ytterbium, neodymium, and dysprosium, and many more. Now coming to the next slide, stereo photography. It is a visual process to view the flow of fluids of varying density. We know that on heating any material of anything, it will change its phase, and from changing its phase, it will also change its density. Taking an example of water, we will boil water, steam will produce, and the density of water and steam is different. So there is a figure which shows us planar photography where we use the plasma pulse laser on a fuel. We can see that the area where the laser is directly struck have the maximum temperature, and near the strike area has less temperature. And also we can see that if we put the laser on for the longer period, it will automatically increase the heating area. Multi-point ignition. The laser beam generated will be divided 2 or more beams by means of diffraction grating. Each beam is directly by optic fiber and focused in their respective laser spark plugs. Sometimes the conventional electric discharge ignition system performs well at normal operating conditions. However, for igniting lean mixtures requires significantly higher spark energy with multi-point ignitions. The higher spark energy will increase the ignitivity but decrease the life of spark plug due to electrode erosion. Therefore, to overcome this difficulty, the multi-point laser-induced ignition is an innovative alternative approach to burn lean mixtures compared to conventional electric discharge ignition system. Now let's study about why we are preferring laser ignition as compared to conventional spark plug. Regulations on nitrogen oxide emission are pushing us towards linear air-fuel ratio. The linear air-fuel ratio are harder to ignite and require higher ignition energies. Spark plugs can ignite linear fuel mixture but only by increasing spark energy. Unfortunately, those high voltages erode spark plug electrodes so fast, this solution is not economical. Natural gas is more difficult to ignite than gasoline due to strong carbon to hydrogen to bond energy. Lasers are monochromatic, so it will be much easier to ignite natural gas. Because of the requirement for increasing ignition energy, spark plug life will decrease for natural gas engines. Laser spark plug ignition system will require less power than traditional spark plugs, therefore outlasting spark plugs. Ignition sites for spark plug are at a fixed location at the top of the combustion chamber that only allows for ignition of the air-fuel mixture closest to them. Lasers can be focused and split into multiple beams to give multiple ignition points, which means it can give a better chance of ignition. As we can see in the given figure, that while using multi-point ignition is more faster and more beneficial than the single point ignition. Now let's see the basic principle of laser ignition system. Laser light is tightly focused so that the intensity exceeds the breakdown threshold of the gas. Every fuel or gas has a threshold value of breaking down, so the laser light should be of that value from which the gas will break down. After the breakdown is achieved, a plasma spark will be formed which will absorb the laser energy and once breakdown has occurred and the laser has stopped inserting energy into the focal value, the plasma begins to decay. After the energy released in the decay is responsible for developing the flame kernel, which ultimately leads to combustion and consumption of the fuel in mixture. Basically, when the laser beam is passed through a convex lens, the convex lens diverges the beam and makes it immensely strong and sufficient enough to start combustion at that point. Hence, the fuel is ignited at the focal point. As we can see in the figure, that a convex lens is there and it is converging the laser into a fixed position, and the following mechanism shows the ignition of the fuel. Let's see the working of the laser ignition system. The laser ignition system has a laser transmitter which transmits the laser with a fiber optic cable powered by a battery. It shoots the laser beam to a focusing lens that would consume a much smaller space than the current spark plug. The lens focuses the beam into an intense pinpoint of light. When the fuel is injected into the engine, the laser is fired and produces enough energy to ignite the fuel. Here are the advantages of laser ignition system. First one, location of spark plug is flexible as it does not require shielding from immense heat, and fuel spray and focal point can be made anywhere in the combustion chamber. From any point it is possible to ignite inside the fuel spray as there is no physical component at ignition location. It does not require maintenance to remove carbon deposit because of its self-cleaning property. Linear mixtures can be burned as fuel. Ignition inside combustion chamber is also possible here, certainly of fuel presence in is very high. High pressure and temperature does not affect the performance, allowing the use of high compression ratios. Flame propagation is fast as multi-point fuel ignition is also possible. Higher turbulence levels are not required due to above said advantages. Absence of quenching effect by spark plug electrodes. There are two main disadvantages of laser ignition system, which are high system cost. This system is very expensive because of the complex manufacturing of laser spark plug. Concept is proven, but no commercial system available yet. As we can see from the above slides, that laser ignition system is very much beneficial than the conventional spark plug, but there is still no commercial use of the system. And the challenges are propagation of laser pulse through fiber optics, development of a compact, robust and economic laser source, durability of windows. Recent development. In Japan, the Japanese researchers working for Toyota have created a prototype laser that brings laser ignition much closer to reality. The laser is a small, high-powered laser made out of ceramics that produces burnt of fuels less than a nanosecond in duration. So the conclusion of laser ignition system is that, in comparison with classical ignition by the electrical spark plug, laser ignition brings several potential advantages that cannot be ignored and that are interesting from both research and practical points of view. The flame kernel is not quenched, thus opening the possibility to improve the engine efficiency. The laser beam can in principle be focused at any position in the engine cylinder, enabling further engine design to be proposed. Temporal control of ignition as well as spatial control are applicable and can be exploited for engine operation with linear fuel mixtures at high pressures. It possesses potential for combustion enhancement and better immunity to spurious signals that may accidentally trigger electrical igniters. One of the potential advantages of laser lies is flexibility to change the ignition location. Also, multiple ignition points can be achieved rather comfortably as compared to the conventional electric ignition system. Although the cost of the lasers had dramatically reduced to an affordable level for many applications, it is still prohibited for technology in important applications such as automotive engines. Now coming to the very important session of this discussion, which is question answer session. Is anyone having any question regarding this topic?
Yes. How laser ignition can reduce the formation of harmful gases?
See, in a normal combustion engine, a mix of fuel and air enters a chamber where it is ignited by a spark plug. Hot expanding gases from the burning fuel therefore exert force on the piston, but because each combustion cycle happens very quickly, it is hard to get all the fuel mixture to burn. The problem is the spark plug can only ignite the fuel at one end of the chamber because of its fixed position. Now in laser ignition system, the laser ignites the fuel in the middle of the chamber, instead burning more of the fuel and improving combustion efficiency. The more complete burn will also emit fuel polluting byproducts such as nitrogen dioxide. That's how fuel pollution is emitted in laser ignition system. Okay then, I conclude here. Thank you and have a good day.